Hello and welcome to a new video. This is a part of my Algebra 1 series. We are graphing linear equations, lesson 3, and we're actually going to kind of move away from the idea of graphing linear equations because we're just going to graph in general and try to get a concept of what that means. And this is something that I'm trying that I think is going to be super helpful for your understanding of what we even mean to say that we're graphing. So we're going to graph using a table of values. So let's remember that a graph is a visual representation of information. So what we've had up to now with linear equations, we've solved them. We've had one variable, something like 2x equals 8, something pretty simple overall. And so basically we could represent that with a graph, that 2x equals 8. It'd be kind of a boring graph. But what happens when we have two variables instead? Because if you're thinking about when we graphed points or when we were talking about slope, we had an x and a y. So what does that change about our situation? We could have an equation like this, y equals 2x plus 1, and we could represent that in an x and a y axis coordinate plane situation. What we would be doing if we represent this as a graph is we'd be saying, if I pick numbers for x, what does that give me for y? And we're connecting, like if I pick x to plug in, the result I get for y, we're saying those two numbers have a relation. We can put a point there, and then if we do that enough times, we can actually see what kind of a shape this has. Now, we've already kind of spoiled it for ourselves that linear equations make lines, but that's part of the reason why we're actually going to do some things. We're going to do a linear equation first, but then we're going to look at some that are not linear, so you can see, some other kind of cool, interesting graphs that we can get. Okay, example 1. We're going to graph the following equation using a table of values. I've got y equals x. That's the equation I'm trying to graph. So what that means is I am trying to create a visual representation of y equals x. I'm trying to create a visual representation of the relationship that is being described between y equals x. What relationship is that? If we just have y equals x, we're basically saying that whatever x is, y is the same thing. Whatever y is, x is the same thing. So I've got a table of values here. We're going to use these values for x. We could use whatever values for x we want to. In this case, we could also just choose y values to plug in instead. But typically, just in general, we would plug in x values because of the way equations are set up. It's usually easier to think about the x values. So if I think about plugging -2 in where x is, we'd basically be saying, y equals -2. Nothing happens there. Y just is -2. And it may be that some of this doesn't quite make sense until one of our next problems where we are having to actually do something when we plug the numbers in. Here, our relationship is basically saying, yeah, whatever x is, y is going to be the same thing. So if x is -2, y is -2. If x is -1, y is -1, and so on. So this gives us points we can graph. We can graph -2, -2. And then we can graph -1, -1. We can graph 0, 1, 1, 2, 2. This looks like a line, right? And we already maybe knew that it was going to be a line because we have first power for y, first power for x. So this is a linear equation. So I'm going to connect these dots, and then I'm actually going to go past and kind of try to keep, I don't want to just like go completely off of the pattern and like have squiggles or something, but my line doesn't need to be perfect, but it needs to look like a line. You'd use a ruler to help you make this look better if you wanted to, but we just want to make it go past our points on either side and put arrows on the end because these graphs are going to be things that go on forever, that we could try to make a huge graph and graph all the way till the biggest number we could think of. Like if I plug in 10,000 for x, I'd get 10,000 for y. I could graph 10,000 comma 10,000 if I had a big enough coordinate plane. I don't, but I could. That's what the arrow is for, to say that it goes on forever. So that's example 1. That's how we do that. Let's look at example 2. So here on example 2, we've got y equals x squared. This is not a linear equation because we have a power that is bigger than 1. X squared has a power of 2. So this is the other type of graph that we're going to learn about in Algebra 1 a little bit later on. But in order for us to think about what it looks like as a graph, we need to think, if I put in these values for x, what do I get? So if I say -2 squared, what does that give me? -2 times -2 is +4. So when I plug in -2 up here where x is, I get a +4. And then I'm going to continue on doing that. I'm going to say what happens when I plug in -1. So this is where you might be getting a better idea of what I mean by plugging in x values. I put -1 where the x is. I square it and I get +1. So that gives me another point to graph. If I plug in 0, if I square 0, I get 0. If I square a +1, I get 1. If I square +2, I get 4. Now it was really important here that we realized, okay, I'm squaring -2. That's -2 times -2, which is a +4. So now let's graph this and see what this looks like. This is not going to be a straight line. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Typically with graphing, if it doesn't look like a straight line, then what we do is we connect it with a curve. Like we could connect the dots here like we used to connect the dots in the good old days as kids, but instead of doing a super straight line, we would actually do a curved line and make it kind of keep going. Again, keep going on either side. And I stopped at -2 and 2. I could have also plugged in -3 and 3, which would have given me +9. But after that point, if I tried to do -4, it would not have fit on my graph. So just throwing that out there. This is called a parabola, by the way. All of our x-squared types of graphs give us something that looks like this. It's pretty cool. Let's look at another one. Example 3. We have y equals x to the 3rd power. Whoa. Okay, so this is not going to look the same as the previous two. We need to think about what happens when I plug in -2. So what happens when you do -2 to the 3rd power? That'd be like saying -2 times -2 times -2. So that's +4 times -2, which is -8. So -2 gives us -8. Then we'd say, okay, what is -1 cubed? That would be -1 times -1, which is +1, times another -1, which is -1. What is 0 cubed? 0 times 0 times 0 is 0. What is 1 cubed? That'd be a +1. And what is 2 cubed? That would be a +8. Then we can graph these. So -2, -8 is down here. -1, -1 is right here. 0, 0, 1, 1, and 2, 8. And again, we could use straight lines. Like if you're just really unsure, by all means connect them with straight lines, because I think this is something you kind of have to get the hang of visualizing. But ideally, we would connect it with a kind of a smooth curve situation happening. This is called a cubic graph because it's x cubed. And that's something that you'll see more in Algebra 2 and later on. So that's pretty exciting. Ooh, this one looks interesting. Friendly reminder, those bars around x are called absolute value bars. And absolute value is where we say, hey, whatever is inside, we're going to make it be positive. So if I plug in -2 into absolute value bars, the only thing I do is say, okay, whatever it is, it's positive. So -2 absolute valued is +2. We're going to do the same thing with -1, and it turns positive. And 0 is neither positive nor negative, so it basically just stays 0. But on these last two, whoop, that looked more like a parentheses. In these last two, we've got +1, which, remember, absolute value isn't that it switches the sign. It says whatever's inside, just it's positive now. And since it was already positive, that means it didn't change. So for +1 and +2, we still get +1 and +2. So let's graph this. -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. Now, this isn't exactly a straight line, but it's kind of like a straight line that was broken in the middle, because what's happening is really similar actually to what we got on the first one. But instead of it continuing down and to the left, because we don't get any negative answers. We end up going up and to the left. So this actually looks like a V. So this is one of the only other cases where we would connect our dots as a straight line instead of a curve. So that is an absolute value graph. That's another thing we're going to see a lot more of in Algebra 2. Now this one may be a little tricky, but I wanted to give you as many different kinds of equations to graph as we could, just so that we have the idea that A, we can graph anything with a table of values as long as we can figure out what the answer is when we plug things in. And B, I want us to have an idea of how nice it is actually to graph linear equations, because our next lesson on graphing linear equations, we're going to learn kind of the shortcut of how to do it so that we don't have to use a table of values every time. So that's nice. Now, when we think about square roots, if I ask you, hey, what's the square root of 25? You would say, well, that's 5, because asking what the square root is saying what two numbers multiplied together give me this thing, where the numbers are the same, right? It's kind of a weird thing to explain. I think once you know what a square root is, it makes it easier, but explaining it, I don't know. Okay, so I'm actually going to start at the bottom and work my way up because I think it's easier. What is the square root of 9? You'll notice I picked different numbers because no one wants to graph the square root of 2. It's a decimal. We don't need that in our life. If I plug in 9 though, if I square root 9, I get 3. So at 9, we're at 3 over here. Let's try 4. If we square root 4, we get 2. So at 4, we're at 2. If I square root 1, oops. If I square root 1, I get 1. And if I square root 0, this might surprise you. The square root of 0 is 0. Once you think about it, though, I think it makes sense. Two numbers multiplied together to get 0. That they have to be the same number. 0 times 0. Now here's another tricky thing though. What happens if I try to square root a negative number? So I don't know if you would have gone over this whenever you did square roots initially, but we are not able to square root a negative number and get a real answer. And there's a reason why I said it the way it is. There is a not real answer. There's an imaginary answer to this. But we in Algebra 1 are not going to concern ourselves with imaginary numbers. We're going to save that for Algebra 2, for simplicity's sake. So if I ask, hey, what's the square root of negative 1? My best answer right there is no, can't do that. So we don't graph anything at negative 1. And in fact, we couldn't graph anything at like negative 0.1. The farthest left thing I can graph here actually is 0. Because I can square root 0, but anything to the left of 0 that becomes negative doesn't work. So what I'm going to do is I'm just going to, instead of having an arrow at 0, I'm going to just have that be like an endpoint and then draw to the right. Smooth curve again and with an arrow on the right side, because it does keep going forever to the right, but it doesn't actually go past 0 on the left. So that, I think, which of these did you think was the weirdest graph? Comment below and let me know, because I can see how you might have said x cubed or absolute value of x or this one, depending on things. Thanks for watching. I know this was a little bit weird, maybe a little bit uncomfortable, but I wanted us to get an idea of just like, what does it mean to graph? What does it mean to take an equation and look at it visually and just kind of see what different things we might come across. Some of these, like I said, 2 of these will come across in Algebra 1 and the rest will come across a whole lot more in Algebra 2 and in pre-calculus. But hopefully this gave you a good first look. So like I said, thanks for watching and I hope you have a great day. Like, comment, subscribe, and I'll see you in the next video.